Hi, I'm Harry Powell, Head of Industry Solutions at Tigergraph. Welcome back to the third part of this series of talks about getting massive improvements in machine learning performance using graphs, graph information, connected networked information in your machine learning. And this is where we start getting really to the cutting edge of machine learning, right? This talk is about graph neural networks. The first talk is perhaps more about use cases. Part 4 will be more about some intuition as to why they are so powerful. This is the bit where I hope you've been looking forward to getting to, and this is the bit that I'm really looking forward to telling you about, perhaps more than anything else. Cool. Where do we go from here? Okay, so last time we talked about the amazing improvements in your existing machine learning applications through augmenting them with graph features, right? So this is a quick win, right? That was the kind of, it's not massively intellectually satisfying, but I think that your finance director or CFO will be pretty pleased with the results, and a way that you can perhaps persuade them to invest more in this because you can show them quick early wins, right? There's nothing like that, right? But this time we're going to talk about how you can get even better results with graph neural networks, right? And it's not as hard as you think. So let's get going. Okay. So if you're like me, you would have been sort of thinking about the stuff that we talked about last time in part 2 about graph features, and you say, well, how can I do machine learning? It's all very well taking graphiness and putting it into an existing machine learning, but what I'd really like to do is find some way of doing machine learning in the graph itself somehow, right? Actually, with those connections, right? Rather than just putting them into a few numbers. That's good, like a shadow, right? Yeah, it gives you the rough shape, but it's not nearly as satisfying as seeing the real thing, right? And doing machine learning in the real thing. How can I do machine learning in the graph itself, right? Okay, well, there's a way to do it, right? And this is the thing. I'm going to shrink myself now as because you're going to want to see the whole of this thing. But this is the business, right? This is the business end of what we've been talking about. Little person, hello, sorry. A simple graph neural network. And when I got my head around this, right, it was like a massive light bulb moment for me. Right? So I'm going to, perhaps if this looks a bit complicated to you, I hope it won't be by the time I explain it. What we want to do is somehow learn in the graph, right? And when you think about graphs and nodes connected to each other, I hope you think naturally about a deep neural network, where effectively a deep neural network is a whole load of layers, where each layer is kind of like a column of weights, effectively, each layer, right, is fully connected to the layer before it and fully connected to the layer after it, right? There's a whole load of connections between things, right? And that's what a deep neural network is. And you then put some structure around it. People think about reinforcement learning and convolutions and all that kind of stuff. If that's stuff you know about, then that's fine. If it's not, I won't explain to you, right? So here is the trick, right? Take your graph, take your neural network, which is fully connected. In other words, every node is connected to every other node, right? And either eliminate or fix the weight at 0 between any nodes that are not connected in your graph. So you start off with your graph, you've created that database, and effectively you've told the graph database, right, what's connected one thing to another. I know that the wheel is connected to the axle, or the customer is connected to that transaction. I know all these things, right? This time period is connected to this time period. You can even do it directionally. So if A is connected to B, B does not necessarily need to be connected in the opposite direction, right? You take that knowledge and you effectively, you set the weights to 0 on your neural network wherever there is no connection in the graph. So you're only left with the graph itself. That's what you do. And you can see this thing, attributes and embeddings and predictions, right? But imagine that that's all you do in your graph database, in your deep neural network. And then you then have you then add on a conventional deep neural network, which has everything connected to everything else, right? You've ended up with effectively a deep neural network that is learning within the graph. That is the result of what you've done here, right? You've kept the basic structure, you've kept this kind of matrixy structure, but you've changed the connections within that matrixy structure in order to replicate the connections within the graph. And it turns out that that this effectively allows you to learn within the graph, and we'll talk about this in the next talk about why this is, but it massively improves the performance of what you're doing. Massively improves the performance of what you're doing. You're going to get much better granularity. In other words, you'll be able to, for example, predict on much smaller proportions of your space, right? So whereas maybe before you could only predict on the number of cars you were going to sell in Europe, maybe you can now work out the number of, going back to my previous employer, Range Rovers you're going to sell in France, right? Or maybe the number of red Range Rovers you're going to sell in the south of France, right? The granularity improves enormously. And at the same time, you're doing that without sacrificing accuracy, right? So before, it would be kind of easy to perhaps predict the number of cars you're going to sell in the world this year, but much harder to predict with any accuracy the number of red cars you're going to sell in Birmingham or in July, right? Whatever it is. You can get both granularity and accuracy out of these models because you've somehow managed to encode the connectedness within your graph. This is the exciting thing. This is the bam moment. This is why I've shrunk myself to one corner of the screen and shown you something a little bit more technical. When you get this, right, you'll see that there is a whole opportunity out there to use neural nets, right, which are like deep neural nets, which are the powerhouse behind loads of stuff that's going on, but use it in a way which allows you to get granularity and accuracy on a limited data set like you might have in your business, right? Certainly not the size of Google's image data set or whatever, right? You're getting this huge amount of power, right? Stare at this screen, pause it, stare at it, think about it. This is the thing, right, for data scientists. If you're not doing this in 2 years' time, I think you're not going to be doing anything, right? I think this is the thing. Whether you do a tiger graph or not, well, I hope you will. I think we've got we've got a really compelling proposition in it, right? But you'll need to be doing this, right, if you're working in businesses, I think, going forward. Graph neural networks, it's the thing, right? And that's what I want you to get excited about. Okay, right. It's time to go back up to my full size, my full glory. I hope you don't, hope this doesn't scare any of your children or maybe your pets or whatever. It's back to full size. Hi. Okay, so a couple of use cases. I wanted you to kind of think about these things. So we're using it right now in personalization use cases. Conventional machine learning thinks about many kinds of personalization. Let's think about two things here: collaborative filtering and content-based filtering, right? Collaborative filtering is like other people like me have done this, right? Content-based filtering is, other products are a bit like that product and therefore you might want it. The problem with collaborative filtering, which is the workhorse of personalization, is that it's pretty bad if no one's bought your product yet, right? The cold start problem is massive for collaborative filtering. A new product, by definition, nobody else has already bought this, right? And so how do you recommend it, right? And in some sense, content-based filtering is a bit like that as well, right? You know that maybe toilet paper, right, and newspapers are both paper, right? I don't know. That doesn't mean that the person who wants to buy toilet paper wants to buy a newspaper, right? Not very helpful, right? You somehow, and that's a real problem with cold start. The other problem that you have is something called diversity, right? In this case, it's not about people, but it's about sets of products. So if I always recommend to you what either you've bought or other people have bought, right, popular things, then you absolutely do boost the sales of popular things, right? But you tend to do it by shifting people away from buying unpopular things, right? And so it may look like your personalization is working, right? Because people do buy more of the popular products, but you're not actually increasing the overall sales of your business as a whole, right? In fact, you may be reducing them because it makes it slightly harder to find or to focus on new things that you might want, but you're not currently buying. Diversity is a big problem. We have found that somehow graphs combine collaborative and content-based filtering in a very subtle way, which allows you to deal with the cold start problem, right? New products, new people, and allows you to deal with the diversity thing. Still offers a much wider range of products, yet remains acceptable to customers, right? Graph neural networks have done that for us, and it's really, really exciting. Second thing is inventory optimization. I guess it's not a great picture here, but supply chains are hard right now, right, for businesses. And getting the right products to the right place, either as a retail business or a manufacturing business or whatever, is really, really hard, right? And the only way they've done it historically is by keeping large amounts of inventory, right? But in order to have the flexibility of your business, to balance the flexibility you need, right, in order to have the resilience your business needs if products are harder to get, right? Balance that with the efficiency your business needs. In other words, I don't want to keep a huge amount of inventory everywhere. You've got a real problem, right? Because you just can't keep huge amounts of inventory in every warehouse, right? And at every point in the chain. Graph neural networks are really good at something called multi-echelon supply chain or inventory optimization. And it takes into account that not just the levels of inventory you might need, but the fact that there may be many different routes for a product through your network of warehouses, factories, channels, outlets, customers, whatever, right? And that sometimes you may need to move product around between those places in an unconventional way, right? And as a result, it allows you to keep lower inventory, but with higher resilience. That's really exciting. We're doing that with a client in Europe. And then finally, demand forecasting or integrated business planning. Here is, I showed you, I think in the first talk, we showed you a bit like this, but this is a different one for cars. Imagine you want to forecast the number of the number of cars, the number of SUVs you want to sell in the USA, the SUVs in Europe, sedans in USA and Europe, right? So you're trying to get a relatively granular forecast, right? And historically, you would have had, even if you had a single machine learning model to do this, it would have effectively treated those 4 different things as kind of separate, right? Or if there was a separation, if they were related, they'd be related in a fairly straightforward kind of way. With a graph neural network, you can say, well, I know a little bit about how many SUVs are going to be sold in the USA by how many cars as a whole are going to be sold in the USA. Maybe the market for cars has gone up, right? So when I see demand signals for sedans in the USA, right, I'm also learning a bit about the demand for SUVs in the USA through the demand for cars in the USA overall, right? And equally for those SUVs in the USA, I learn a little bit about them from how popular SUVs are in total across the world, right? Maybe SUVs are becoming more fashionable, right? So when I see a demand signal for SUVs in Europe, I'm learning a little bit about the demand signals for the SUVs in the USA through the demand for SUVs, right? And don't just limit that to SUVs. Maybe the demand for red cars has gone up. Maybe Victoria Beckham has bought a red car. I don't know, right? And suddenly demand for red cars goes up through the demand, and there, so we learn for the demand for red sedans, we learn a bit about the demand for red SUVs or whatever, right? There's a whole network of different ways these things can be related, and the information can diffuse through the network to do that. This is how we do integrated business planning with graph neural networks. We're doing it with a client in Europe right now. It's super powerful. Right? It's super powerful. And you don't even need to limit this to demand. You can start thinking about how that demand will be supplied all in one network, right? Passing messages around, optimizing to understand how it's all going to work, right? Super, super powerful. Okay. And one of the things that gets me particularly excited is so here's a funny picture for you, right? The background is actually a paper by Amazon. You can get it. It's on the on that thing, try and point to it, that link there. It's how Amazon are doing demand forecasting in their marketplace. right? It's really granular, it's really fast moving, needs to be really accurate. It's that's how what they're using, and they're using the fundamental bit at the top is a graph neural network, and then they've used some kind of long short-term models below for the time series element of it. I don't know if I do it that way, but that's a way of doing it. They are using this right now, graph neural networks right now, for their demand forecasting in one of their key products, the marketplace, right? And so the question is, do I need to be Amazon in order to manage this, in order to put this into production? Do I need to be Amazon? Do I need a gazillion super clever people? Well, you probably need a few kind of super clever people, right? But they can do this with Machine Learning Workbench, because Machine Learning Workbench links together, right? The graph at the front end with, well, in Amazon's case, I guess it's AWS and SageMaker, but in Google's case, it's kind of Vertex AI with GCP. Microsoft's case, it's Azure ML, TensorFlow in the background, or whatever it is. Machine Learning Workbench makes that possible, right? So I'd really highly encourage you to think about that. So when I'm talking about those use cases in personalization, in inventory, in demand forecasting, this is within your reach, right? This is within your reach. The tools are available to do it. And I'd highly encourage you to look at it. As I say, I think it's the thing, right? The balance between kind of granularity and accuracy, right? Those tensions between flexibility and resilience, right? All of those things are key to how we manage businesses right now. And graph neural networks gives you the best chance of balancing those things out. So, summary of where we got to this time. Graph neural networks give you access to the highest performing machine learning models, the highest performing machine learning models available out there. Yeah, you know, there's some cool stuff in convolutional neural networks and, you know, all that stuff, right? But for businesses, I think this is the thing. Graph neural networks is the thing. And they're already being used, right? The next talk, we're going to talk about a bit of intuition as to why they're so powerful. But until then, perhaps you want to go back and stare at that slide about how they work. When you get that, when you understand, and look, you're all clever, right? You probably have already, right? But perhaps it took me a bit longer. Whatever it is, when you see how you're encoding the connectedness of things right into the soul, into the heart of a deep neural network, and then optimizing them all at once, then you'll see why this has such enormous potential. Thank you very much. See you next time.